Afternoon, everybody. So thanks to the PWI for having me and Nick for the invite. It's a real pleasure to be here, and it's always more nerve-wracking in front of people who know what the subject is than other audiences. So here goes. Yeah, I wanted to really talk about what's the first thing that springs to mind when safety and infrastructure and technology, and it is about taking the task away, doing the task differently, doing it remotely. We've seen lots and lots of examples of really, really good technology that is, first of all, eliminating the task. How can we do it differently? How can we use video? Can we use drones? Can we use trains? There's so many different ways that we can apply to take those tasks away. Then replacing the hazard. How can we bring in technology to substitute so that people don't have to go to site, so that people can, I guess, look at things remotely? What engineering controls can we apply? What admin controls can we apply? I think we all know this triangle is really, really important. But the thing that struck me was we've launched the S&C Alliance. I'll talk a little bit more about that. And Nick straight away was on there, as he always is, with a challenge. How can we 100% inspect, maintain S&C without putting a human in the gauge envelope of a passing train? So I'm going to try and talk about some of the things that I think go quite a long way to getting there. We're definitely not there yet, but I think the technology that is available, with some collaboration, with some integration, probably a few new bits, we can probably get there. So hopefully paint a picture. So when I was at Network Rail, the last thing I did was looking at optimization of Msts, which is basically how can we go to site less often? How can we remove those tasks? And one of the trickiest areas is clearly around switches and crossings. And so we sort of mapped out all the things that we should probably address if we're going to successfully manage and maintain S&C so that it's reliable, we do it efficiently, we only go there when we need to. And one of the feedback I got, which I didn't really like, was that's a bit ambitious. And it's like, well, if we don't have ambition, what's the point? What are we getting paid for? So anyway, I would say he said that. But anyway, first of all, you've got to set out a vision. And different bits of the railway need different visions. There's no point applying the same maintenance regime on the West Coast Main Line as there is on a more rural line, for example. So we've really got to think about what we're trying to achieve with that bit of infrastructure. And then you can start to think about how you're going to maintain it. So I'm a huge fan of risk-based maintenance, reliability-centred maintenance. I think it's becoming more and more part of the railway life now. There's still further to go, but it really is, I think, paying dividends, getting people to track when they need to be in track. The insight tool's going to be a massive part of that, helping really direct people to where they need to get to. But it all first starts off really with accurate data. We suffer from inaccurate data in the railway. When we did some of the work, we were trying to push out the frequency of slide chairs, so we arranged to go to Scotland to do some testing. We got there, they got rollers on. So it's like, how did they not know that we got rollers on this set of S&C? And it's because the data isn't accurate, it's not loved, it's not valued in the way it needs to be. So that's a big part. If we fix that, and we've got the tools, we've got AVA, we've got downward facing video. All it takes is somebody to sit there, watch it, and check ellipse, change it. It's possible. And the other bit is competence. Competence is a big issue. I think the amount of repeat faults that we get are probably due to lack of competence. And it's not because people are incompetent, it's because they don't necessarily know what the right fix is. They don't know what is the best approach. How many times do we measure S&C up incorrectly, for example? I think about 70% of S&C orders get sent back for a technical query. That's just not acceptable, and that's because people don't know what they're supposed to be doing. It's not because they're doing it wrong on purpose, it's because they don't understand. So how do we train them better? And are we organised, I guess, for a modern infrastructure? So having S&T and P-way separately, for example, probably not the best way to maintain switches and crossings. But then it comes on, so once you've got your accurate data, you've sort of set out your risk-based maintenance regimes, you can then amend your cyclical tasks, so you're only going to site when you need to. You have an output specification for that particular asset or that particular set of assets, that route, and then you can work out what infrastructure monitoring you need. So how often do you run the measurement trains, what Connox devices do you fit, so on and so forth. And then that all comes together in the predictive analytics, all the stuff that Alex has talked about, bringing all that data together into a central place, so it's we get the best possible prediction. They will improve over time. We shouldn't expect perfection from prediction. it's an art, I guess, not a science almost. I know it's a science, but it takes time to build the right algorithms. It takes time to get them to be perfect, and we need to accept that. We shouldn't let great get in the way of good, and I think that's something that's, I think, really good in the IM program I'm going to talk about as well. And then you get to the optimised intervention, so you go to the right place, the right time, and the asset doesn't fail. The final bit is getting the information to the guys on the ground, and that is related to training as well as what they're doing. So not only do they need to know what task they're doing, they need to have some way of checking how that task should be performed. Some of these, I mean, how many different types of S&C are there out there in the network? There's probably hundreds. How is somebody supposed to remember every single bit of every single type of S&C if they're only going there once a year or whatever? So we've got to find a better way to give them the information they need at their fingertips, alongside, you know, what's the failure history, alongside what maintenance has been performed recently. So bringing all that together, it's a huge, huge undertaking, but if we don't start, we'll never get there, and that's really my plea in general. Just some examples of some of the great, amazing data sources that are out there. So top left is a pitch from plain line pattern recognition. That gets chucked away mainly. Why don't we make that available to the engineers, to the section managers? It wouldn't take much. I think there is some work ongoing, and I might be doing a disservice, but when we built the system, we threw it away deliberately, and then 10 years on, we're still throwing it away. That just doesn't make sense. Ground penetrating radar has been fitted for 15 years. How effectively is it used? I don't think it is at all. Connect's obviously new, change in process. We'll talk more about that later. The AVA stuff, the downward facing, we've talked a lot about that today. That's going to be a step change for me. And the great thing is, when we tried to do it previously, you've got to do this, and this. With that project, they've taken a different approach. They've worked out what can you do today, and what does that change, and then what can you do tomorrow, and what does that change, rather than saying it's got to do this, otherwise don't bother. It's a much better approach. Incremental approach is so powerful. Things like back-to-back gauge, I think it's generally accepted that it's the best way to measure S&C. Very few people use it. I think the only one I know who's mandating it is Dan Collins in Western. Fair play to him for it. Why isn't anybody else using it? It sets your S&C up for success, but it's just not. Again, it's that system piece between track and S&T, who should be doing it, so on and so forth. Points condition monitoring, and then the right tools, making sure that we're doing the best possible treatment. That means you need to go to the asset as infrequently as possible. And then LiDAR is my other favourite one at the moment, or the Fugro system. There's other systems as well, obviously, but they go out, they survey, they store the data. We use it for the purpose they've surveyed it, and then we don't do anything else with it. Such a rich set of data out there captured that Fugro have got in a database. Why aren't we doing more with it? Why aren't we using it to look at tunnels, and if tunnels are changing? So many opportunities. So yeah, have we got the right data? Is it in the right place? Can we get it at the right time? Does it create the right information? And are we doing the right treatment? So what do we do? So we're all about, I guess, artificial intelligence. The whole premise of Connux was to be an artificial intelligence company. 4 guys left university, decided that they wanted to set up an AI company, and then tried to find something to apply AI to, and got involved with Deutsche Bahn, their Mindbox program. So they got some startup funding. Deutsche Bahn identified a problem, measuring vibration and displacement of S&C, and they created a prototype. And I think 4 years later, they got their device in the ground. So the whole purpose of it is to monitor the S&C. So you've got the eyes on the asset, virtual eyes, listening to the asset when you can't get eyes on the asset anymore. That's the really big thing for us now. People aren't going to site when trains are running, so you're missing those oral clues. You can't hear things going over the asset. Get my words right. And then we detect anomalies and provide that feedback. One of our big things is that we work with the engineers. We don't just sell devices, we sell a service. We interrogate the system on behalf of the engineers. We work with them to understand what work have they done, or what have we found, and what work do they need to do. And we think that's probably the best possible approach, because the busy people, if they're not guided through the data, they're probably not going to get a chance to look at it and use it as effectively as possible. And then ultimately, they can prevent failures. Longer term, we want to get to prescriptive maintenance, but we need lots more devices. We need a huge feedback loop so we can build the models, so we can say, when we get this signal, you need to do this work. That's not there today, but it will come in the future. I've got no doubt about that. And the final bit is validating maintenance, so we can tell if somebody's done a good job or not. And that's really, really powerful, because then you can understand why didn't Why wasn't that treatment successful? What went wrong? Is it training? Is it the asset just isn't fit for it? So you can start to make different decisions, and we've seen that a lot at Doncaster on our trial sites. In terms of the device, it's been in the field for 4 years. We've got around 1,000 devices worldwide. Hopefully by midsummer we'll have about 200 in Network Rail, which is really fantastic, and we're really looking forward to seeing the results from that. We've got product acceptance last August, and we've just revved that in April. We can support down to 25 miles an hour. Below 25 miles an hour we see quite a lot of noise in the signal. We are working to improve that and lower the speed further, but at the moment that's our minimum recommended. Just because we get better results above 25 miles an hour, and obviously we can go to any train speed in the UK. Can go on any S&C. It's autonomous. It's a battery. It's got GPRS, so it's got SIM cards in there. Sends the data off every night. So it's really simple to fit, and we have got a really unique and mature feature set because we really do invest in not only the core purpose, which is about displacement, which is about acceleration, but things like network load, maintenance quality check, they're all things that we believe can add value to the engineers, and the engineers help us form the forward-looking product. So displacement monitoring helps Network Rail to comply with their standards, really. That's the crux of it. There's 2 clauses there, I'm not going to read them out, but basically you need to measure the voiding. If you're not on site and you haven't watching trains over, how do you understand the voiding? This enables you to do that from your desktop. So again, remote, safe, really good understanding of asset condition. Next one, vertical acceleration insights. This is one of my favourites. So the system identified that the acceleration had changed quite dramatically at one of the S&Cs. So they went out, did an investigation, found 2 squats. Then I think the engineer wasn't happy, so they looked again and found the weld wasn't great, so they painted it white. Then they went out and watched the train over it, which hopefully you'll see here, if this works. So you can really hear that's getting a lot of hammer. Nobody probably would have been at that site if we hadn't sent them to it, because they're not there when the trains are running. Why would you send somebody in daylight? Because they're not going to be able to do a productive task. So it gives you that remote access to it. And ultimately they've had to change that crossing. So that could have led to a crack crossing. They couldn't dig the squat out, it was too deep. And then maintenance quality check. So was the work you did effective? So we provide a dashboard, we provide it in the UI as well, the user interface, and it again helps, are you doing the right root cause? At the moment we're doing some things with Sheffield around, they're doing some MSP and they're doing some hand tamping, and they're trying to compare the results on different assets just to see what gives them the best possible result. And then we looked at some tamps. This isn't in the UK, but we found that at the crossing, 75% of the tamps didn't achieve the quality measure that the infrastructure owner had set. So that's 75% of the time the crossing is not improving. So it's either not going below the 3 millimetre threshold that they set, or it wasn't improving by at least 15%. And then 2 months later, a further 10% of those had gone back to normal. So tamping isn't meant to last 2 months, is it? So you're not getting the outputs that you expect. And we have seen similar in the UK as well. So what could you do differently to make sure you get the best possible job, best bang for your buck from what is a very expensive activity? And just some of the benefits. These are the benefits that East Coast came up with when we worked with them. Obviously safer workforce, reduced on-site tasks, fewer repeat visits, less firefighting, all things that are really help keep our people safer. Improve passenger experience, reduction in delay minutes, and ultimately we believe huge increase in major component life. So many crossings fail early at the moment. Hopefully we can be part of making them last their design life. And then onto, it's almost like a side project, but it's not, because it's all part of what we want to achieve. We've got together as the supply chain, because we do think there's a huge amount of power in collaboration. So between us, Interflon, Stay Tight, we've got Neil Denton involved, got Brett Nelson, Darren Sharp, Emily. We need a bit of diversity. It's a very undiverse picture, but I guess that's a reflection of where we are, and hopefully that will change in the future. But we're working together. We've got a WhatsApp group, we've got a LinkedIn website. We try and do shows together. So we're at Bletchley and Rugby in Northampton last week, and just taking people on a journey of how they can maintain their assets differently. So we can monitor it, change the lubrication so you go in there less frequently, change the bolts so that you know they're not going to come loose, use a flexi lube because it's better than the existing. All those elements, use AVA obviously just to get the general understanding of the infrastructure. All those elements coming together are really, really huge. I've forgot DWG as well with the spike fast. That stuff is amazing. All those bits and pieces can come together to create, I guess, a system around S&C maintenance. And I guess this is how it all fits together, really, because people are like, why are you working together? So you've got Stay-Tight can change the bolts, we can monitor it, FlexiLube will change the lubrication, Interflon can do the slide chairs, can do the rail face, so on and so forth, and Fast Patch, Spike Fast. And that's probably a one big circle picture. So you can see how it all fits together nicely to, I guess, deliver a holistic solution for the section managers, the maintainers. A lot of the time it's about awareness. When I did the MST work, the biggest thing that I found was that most of the answers already existed. Just people weren't using them. People had tried it, it didn't work. Say it's crap. It's like, well, if it works there, why doesn't it work there? Is it because it wasn't applied properly? Were the people not trained properly? Really getting to the root cause of why things haven't been successfully applied. And I guess that's what we're really trying to do, just try and raise awareness about what is available, because a lot of the answers to Nick's challenge do already exist. With a little bit more collaboration between Network Rail and the supply chain, I think we can probably achieve that goal. Thank you. Oh, sorry, missed this. I love this slide. So this is the result of, I guess, one delivery unit really focusing on getting rid of switch defects. So using data, changing how they lubricate the switch blade, monitoring the assets, just really applying all best practice. So in 2018, 300 defects, 2021, 120. That is a hell of a performance. And if they can do it, why can't everybody else? So thank you very much.